There are a lot of people still outside, but probably it is not a bad idea to start, to be possible to cover at least part of the content. So, welcome to this morning session. I know that it is very difficult, extremely difficult after one-day conference and a lot of content and probably something after this conference. Day to come again early morning. Today we will talk about Cosmos DB. Is there anybody who has experience, or is there anybody who even heard about Cosmos DB? Okay, it will be challenging for me because I will try to explain in interesting way what exactly is this animal, and I will try to attract you with that. So, few words about me. Some people joke that I'm coming from the dark side. That means my experience from the past is mostly up to Microsoft-related technologies, but I can say that my current experience is not so technology related, mostly technology agnostic, not technology specific related, and I'm mostly focused on cloud solutions, data platform solutions, and Internet of Things. In this context, for good or for bad, I already have some experience with this solution that we will discuss, Cosmos DB. And initially, I prepared quite aggressive schedule, but depending on your interest and your experience with related technologies, similar to Cosmos DB, we can adjust this talk to have the best fit for you. Anytime when I talk about specific solution, I try to explain good and not so good things. That means I'm trying to be a little bit more objective because there is no perfect solution, as you know. So, the main question, what is Cosmos DB? As I understood, for now, probably I need to start initially with some words as introduction because there are no people with this specific experience. So, you can imagine that this is software as a service that propose different APIs for different kind of storages. But these storages are NoSQL databases. They are not relational databases. We have DocumentDB. DocumentDB is document-oriented solution, and it is somehow similar to MongoDB, for example, and CoachDB, for example, but with some differences. We have specific API for MongoDB, and we can use it also. We can use graph databases based on Gremlin, and we can have table storage, but a little bit more complex with additional features, table storage. So these all services are behind the name Cosmos DB, and we have some common things that we need to set, like namespace and client and some other abstractions to use these services in the same way. We already discussed with some of people here at the conferences that there is a similar approach, but for relational databases provided from Amazon and RDS. Actually, with RDS, they provide different relationship databases, software as a service. Here, the difference is that we have NoSQL solutions. it is something that probably is expected when you have cloud-based solution to have globally distributed database. That means in all data centers, you have this service and you have options to provide disaster recovery, geo-redundancy, all these features that are up to more than one location. One of the most specific things is that SLA that is provided is very good and we have very low latency. Probably all charts will be not so meaningful, but when we have some numbers, for example, when we read after second millisecond, it is possible to have already bytes when you read, and it is for more than 50% of the cases. For almost all cases, we can start to receive data, for example, after less than 10 milliseconds. There are some statistics that are probably not so interesting regarding to the short timeline that we have. That is the reason to be focused mostly on the main features, main advantages, disadvantages, and some considerations where you are able to use this database. Usually, when we have databases, we are not able to have at the same time three things. Probably you know: scalability, high availability, and what? Consistency. Do you know how we name this theorem? There is one CAP theorem related to these dependencies. So, it is something that really is not possible to be solved, but if you have some service with quite good flexibility features, we can change our consistency models, we will see a little bit later, to be possible to have more consistency, instead more availability, or on the opposite side. So, there is something that probably some of you heard. A few years ago was released so-named DocumentDB. DocumentDB is document-oriented solution that is something similar, as I already mentioned, to MongoDB. But it is a solution that provides SQL syntax, and it is easy for people who work with relational databases to start using NoSQL document-oriented solutions. The start is easy. It is not written in Java, .NET, or some modern frameworks. It is implemented using C and C++ from scratch. It is still not open sourced, but it is mostly because it is software as a service. But because of some other things that we will discuss later, probably we will have also soon open sourced code base. I need to add some pictures. Probably some of you believe, probably some of you have considerations, but really Microsoft Azure as cloud platform now is focused even more on non-traditional for this company technologies. That means Linux is running for me better, and they are supported all main technologies that we use for developing of applications. There are several things that is good to know. I already tried to explain these things about globally distribution, consistency model, multimodal database, low latency, indexing, and possibility to be flexible with setting of scalability and so-named throughput. Models that we already mentioned, and some possible competitive solutions to be easier for you to recognize where is Cosmos DB. You can have experience with Amazon DynamoDB, for example. It is also software as a service. You can have experience with IBM Cloud, probably. I already mentioned MongoDB, CouchDB. These solutions are very similar like concept, especially for document-oriented databases. Well, probably the most important is where to use these kind of solutions, because it is the main goal of this presentation, to understand where you can take advantage, where is really reasonable to consider some solutions that are with Cosmos DB. Well, one of the most important thing is, of course, if we have globally distributed mission-critical applications. That means globally distributed applications are implemented very easy because we just need to set several things. Nothing additional from our side. Also, it is one of the perfect solutions for Internet of Things. Really, my experience started with Internet of Things and DocumentDB in the past, because you have scalability, and scalability with additional features that we already considered is one of the most important things when we talk about Cosmos DB. It is possible to use DocumentDB and in general Cosmos DB different APIs for most of the things where we have relational databases. That means to use it for settings, for personal data. It is good to know that solutions like Cosmos DB are not up to cheap storage. These solutions are somewhere in the middle between relational databases and cheap NoSQL solutions. We have a lot of functionalities. We have quite powerful NoSQL solution, but it is not so cheap. And if we consider to use it for cheap storage, for example, going back for Internet of Things, your solution will be not cost effective. It is good initially if you consider design of your application to have this in your mind. If you need to have data that is operational data, and this data will be used quite often for some kind of analysis, reporting, more complex operations, and this data is possible to be scaled more than 1-2 terabytes, for example, in some moment, probably you need to have this kind of solutions. If you need to have just small amount of data that is operational with some more complex analysis on this data, you can use relational database. So, any kind of popular solutions are also up to this kind of systems. Retail, e-commerce, gaming. Gaming is quite good, also together with IoT, because we will talk probably a little bit later. We need to have a lot of raw data that is collected from some kind of end users or sensors or something else, and we need to process this data. Process data usually is stored in something like DocumentDB, I mean document-based solution, but raw data is in some kind of cheap storage. Also, serverless applications are something that can be used quite easy and effectively with this kind of service like Cosmos DB. So, usually I go in some details up to DocumentDB and Cosmos DB when attendees have experience with Cosmos DB. Now, because you're without specific experience, I will try just to mention a few things and to go forward. I could say that if you have solutions implemented with DocumentDB, you can migrate it without any additional changes, these solutions to Cosmos DB. Just this storage is working in the same way. There are some additional features that are added, but a whole syntax, everything is the same. So probably we can continue a little bit forward about data. About data, we have several different storages, as I mentioned. JSON documents that are used are up to DocumentDB. When you use MongoDB, for example, you will use data through MongoDB API in the same way like in MongoDB, but internally you will have additional system properties. It is behind the stage. So it is transparent for developers and people who use these applications, but the data format is equal to DocumentDB, not to MongoDB. It is possible to use graph databases, as I mentioned, and table storages. Well, probably the most important is to see what exactly we can use and what is the specific thing that really give us advantage. Imagine that you have a team with people who work mostly on relational databases and solutions where all databases are like Oracle, MySQL, Microsoft SQL Server, PostgreSQL. In this case, it will be very easy to let these people start using document-oriented solution like Cosmos DB. Why? We will see when we go through the syntax. Behind the stage, there is one specific thing that is inheritance from the past. We had years ago very, very popular SSD disks with 10 gig size. When they started to propose this solution, they started with this size. And this size stay like, how to put it, unit for sharding that we use. I mean, 10 gigs is the step that is used to increase, decrease the size of collections. It is something that came from 4 or 5 years ago when this solution is designed initially. Now, it is just good to know these things. Also, it is good to know that indexing is provided for all fields automatically. Do you think that it is a good idea if you have solution where all your fields are indexed? Why? Exactly. When we have insert or if we edit data, we need to regenerate indexes. All these operations are async, of course, but it needs additional power and it decreases also the efficiency when we use these solutions. If we have NoSQL solutions, the main advantage is when we especially ingress data, when we collect data, when we insert data, it is faster. More or less, depends on the settings, of course, but it is the main advantage. When we have indexes on all fields, it stays slower and slower. By default, usually all fields are indexed, and we can change the settings and to leave only fields that we need to be indexed. In this case, we will improve the performance. So, I suppose that this schema is recognizable as size of the boxes and text, hopefully, from your position, just to explain especially what we have in general. We have one abstraction that is named database account. You can imagine that database account is something like namespace. And you can put in this namespace other abstractions named databases. Database is also not physically existing element. It is something that logically includes different collections. We have for each so-named namespace or database account additional option to add media files with big size up to, I'm not sure how many gigs, but it is something that sometimes you need when you have referral data to some kind of media. Users. Users usually are not used for login. Users usually are used internally with different set of permissions for this kind of solutions. It is possible to use users for login, but it is not the main concept of this kind of solutions. Also, number of users is limited. Initially, it was only 5. After that, they increased this number, but the case is that we use it mostly to manage role-based policy. Collection is the main element. Collection is the main thing that you usually need to manage using NoSQL databases, document-oriented databases. Collection can be Swiss-sized or can be partitioned. In all cases, we can have access with a REST API and SDK to the whole content of specific collection. Documents, of course, are the second thing that we need to know. Documents are JSON documents with some limitations. I think that I missed here these things, or probably on the attachment. No, attachments can be up to 2 megabytes for each document. We have also stored procedures. Stored procedures are very similar to the approach that we have in MongoDB, if you have experience with MongoDB. Is there anybody with experience with MongoDB? Oh, much better. So you can understand easily most of the content. So usually when we have DocumentDB API, like Cosmos DB, we can manage data in 2 different ways, using SQL syntax and using JavaScript functions on the server side that are especially these stored procedures. Stored procedures are executed in transaction mode. Other queries are not executed in transaction mode. So if you need to have transactions, you can implement your data processing using stored procedures. Triggers are stored procedures hooked to specific events, and triggers are support. And user-defined functions are what? You have it in other solutions also. JavaScript functions that are not related to specific collection content. All stored procedures can have access to the context of the specific collection. That's good. That is not also good. Why this is not so good? Because we need to have these stored procedures for different collections. We need to copy these stored procedures. That is the case, but from another side, we have some kind of isolation for each collection of all things that we can access, and of course, it is trade-off when we have advantages and disadvantages, what is better and what is not better in specific design. So, I already mentioned about the indexes. Indexing can be also seen in easier way when we have a request using REST queries. Actually, all these services provide REST API, so we are able, I think, here I have schemas, to demonstrate how we can use queries and using REST API. And of course, if we have indexing, it will be relative good performing, otherwise it will be pain. I will skip some things about REST API because probably we will have no time. About queries, we will see a little bit later. Doesn't matter that these examples are not on Java. The syntax on Java is almost the same. You need to create one logical element that is representing our database client, and we are able via this logical element to access all other elements. There are specific system properties, as I mentioned. By the way, do you know what is ETAC? Did you try? Sometimes optimistic concurrency, when we have writing and from different instances to our server, and if we send some data, we get specific property that is up to the timestamp. When somebody else is trying to read this data, to get this data, it is possible. But if somebody else try to write this data, but you are the first one, it will be prevented, and there will be error returned, because ETAC regarding to the timestamp and the moment when data is got and data is changed is different. So there are a lot of details. Something about throughput. As I already mentioned, the computing power that we can use for DocumentDB / CosmosDB is up to one property named throughput and one foggy unit named request unit. Why I say foggy? Because it is quite difficult to measure this unit. It is unit that can help us to compare different tars, but it is unit that is explained a little bit not clear. Why? Because it is a computing resources that we need to read 1K document with and this document to have no more than 10 unique property values. From our experience, you have for a relative simple document, for example, data from sensors with 10, 20 properties, we have 17, 18 request units to receive this data. So, we have a little bit different model now. I mean that in the past, this service started with several fixed tars, S1, S2, S3. That means tars with different throughput. This throughput was something that is not possible to change. It was not possible to change the tar of the collection. But now we have so-named partitioned collections, and it is possible to change the throughput and to change the size. Frankly, if you are not careful, you can pay a lot for these partitioned collections. It is important to optimize your expenses, and that means you need to know how much power and size you need, and you can manage this automatically. We will see a little bit later, probably. And there are also single partition collections where you can scale the throughput, but you are not able to scale the size. Usually, there are some sample prices, but these prices are prices for the minimal size and minimum throughput. That's the reason to say price start from $6 or something like that. Usually, if you have a partitioned collection and you have not so much data, this partition collection will take probably around several $100 per month. About partitioning, I already explained some things, but it is good just to mention that all other services have similar approach. Partitioning is available for other APIs in very similar way, and this is something that help you to switch from one storage to another storage. I just added a little bit more content because of the possible details. It is possible if you need very, very high performance to increase number of your partitions to be possible to cover these requirements. For example, if you have, for example, gaming, live gaming, or if you have, for example, live betting, where many people bet for something and change bets a few seconds after that. In this case, probably you will be in situation to consider even higher throughput. Usually when we use partitioning, we have similar properties for all storages that we use. As I mentioned, partition key that is named in different way. So let's go a little bit more in detail regarding to how we use this service, the database as a service, in real life. There are several SDKs we will see. Most of samples that I have are with .NET, but you have same samples with Java. There are same samples with Node.js, JavaScript, and Python. So it is possible to use all these frameworks, or if you use different language, it is just possible to create requests against REST API. I have friends who created a library for iOS to be possible iOS applications to collect DocumentDB data, and it is not very difficult. Because we have not a lot of time, I will skip some details that are up to more considerations. Creating of database, creating of document, it is something that is based on the API, and we async create via this logical element that is DocumentDB client, all these elements. The most important thing is that we have one property for most of elements that is named self-link. Self-link is the direct URL via REST interface to your specific resource. And if you need to access directly this resource, it is possible to use this self-link. When we have any kind of SDK, it is just added like element in the syntax, and internally client makes several requests to the database until the right self-link is received. It is something behind the stage, but it takes time. If we need to have additional performance, to improve the performance, we can cache these self-links. Probably we will be able to see this a little bit later. Usually we have this kind of simple sequence syntax. We have not time to go in details about all examples, but SQL syntax is something that is probably easy to be understood because it is one of the few NoSQL databases supporting this kind of syntax. Probably you will say how we will be able to have relations using SQL. And what about joins? Joins here are not to join element between different collections. Joins here are mostly to have projections. If we have JSON documents on many levels, we need to have links between elements on different levels to be possible if we have requests to have, for example, as a result, something like flat list with these properties or these fields that we need. So mostly for this reason, joins are added here in the SQL syntax, but you can consider these joins like self-joins. That means if you have several, if you have hierarchy in one table in relational database, to use joins to the same table to be possible to present flat projection of your data. There are some limitations because joins usually need a little bit more power. It is some approach. There is some approach when you need to have more complex queries. Usually, you need to ask the provider, in this case, Microsoft support, to increase your limitations. It is mostly to prevent solution from unnecessary consumption of different resources. And in this case, usually support will review your queries, and if you really need your limitations to be increased, they will do that. So there are a lot of examples. I will show you after 5 minutes how you can play even if you have no any experience with DocumentDB. Exactly using this URL, documentdb.com/SQL/demo. It is in my presentation and you can get it after that. There is live demo where you can play with different queries and you are able to see if these functionalities are fine for you. Also, there are several different solutions in GitHub, open sourced, that you can use to start with Cosmos DB, like DocumentDB Studio. These solutions provide you whole code base that you need to create all these elements, to manage these elements, and it is much easier to start using some already created solutions than if you need to write these things from scratch. Samples about user-defined functions, we already discussed that it is just JavaScript function. If you have DocumentDB Studio installed, you will be able to see what you created and what is the metadata added in different color. Here is added in the green color, because these kind of solutions need to have, of course, additional metadata to be possible to have information about your real data. So, about queries, we will have at the end probably some demos. About stored procedures, usually we create stored procedures and execute it from the client, because the client SDK proposes these functionalities. Pre-triggers, post-triggers, again, can be executed in this way. Again, I will go forward because of the time limitations. Okay. About transactions, already I explained that you need to have transactions in via stored procedures, and you are able to roll back in this case automatically. You have no need to manage anything. And let's talk a little bit about the performance, and after that to try to demonstrate some things. So, there is a huge difference in the performance regarding to the settings. Usually, if you start using such kind of solution, you have by default so-named gateway mode. That means you need to pass through one point, entry point, for all your collections. It is possible to use direct mode and to access directly specific collections. This could be done transparently, and it is question of settings. Also, protocol that is used is important. If you use TCP, performance will be much better. If you use HTTPS, performance will be slower. These are things that probably each of you can consider by himself, but it is good initially to know that these settings are very important, especially for this solution. Also, if you have distributed solution, any kind of communication between instances that are in different locations, of course, will have some delay. It is not possible physically to have communications using different data centers and thousands of kilometers and to have no delay. So consider also where are your location, your instances located. About self-links, usually we do caching in this way, but I added here string. Usually we provide some custom mechanism of caching of these self-links if we use quite often specific resources in these databases. There is one thing that is very specific. Probably it is a little bit early for you, but from another hand, it is good to know that there is specific related to a regional failover that is supported from this database. Usually, if you add support of these settings, that means, for example, if we have our cloud solution in West Europe, for example, West Europe for Azure is Netherlands, and we can have in North Europe, that means Ireland, our failover instances. But what happens if we really have some kind of incident? In reality, it happens. I already mentioned to some of people that, for example, in China, one data center had some issues because there was disaster, and they relocated all systems to another location. In this case, we will have this kind of situation. Your primary instance, that is, for example, in Netherlands, will be changed to Ireland, for example. You will start to use location in Ireland to write data, and you will be able to read data from different places when it is possible to go up again the original first instance. If it is in Netherlands, the case will be that your first instance will be only read-only. It is quite complex and difficult to change the logic with your first write instance, and that's the reason this to be up to the customer. But if you work on such kind of solutions, please consider that if you use failover functionalities, it will be implemented in this way. So in first site, you will have the second location functional like main, and after that, your first location will just stay second when it is up. Nothing about restoring. If you need to have really global master replicated database, you need to use some kind of routing service. We usually use traffic manager, and we need to have different primary instances in different regions, and to have secondary instances that are synced with primary locations from other instances. In reality, it could be done with any technology. Just it is example that sometimes it is not possible to change the physics of the things, and really, if we need to have really multi-master global solution, we need to duplicate everything in all locations. We will skip, because we have no time, things about MongoDB API, but you need to change just the connection string. Nothing interesting. Table storage is something like premium table storage. That means it is not simple storage. It is relative expensive table storage with additional functionalities. And Graph API is also implementation of Gremlin that supports scalability and have high availability, disaster recovery, all these features as other services. So, is there time for demos, or you prefer to stop and we can discuss out of the room, of course, about some examples? Probably 1 minute, just 1 minute. I will show you just some specific things, but just for a few seconds. This is the place where you can try SQL syntax, and you can use different structures. You have no need to have account. You have no need to subscribe for Azure to try these kind of queries. It is something like playground where you can execute different queries. You can change these queries, and you can see how it works with filtering, sorting. Also, there are geospatial functionalities that are pretty well supported also. We will have not enough time. You can download from GitHub this DocumentDB Studio and many examples in many different languages. That means, as I mentioned, also it is possible to use Java, it is possible to use Node.js. One of the most important things when we create this kind of database is that we have keys that are generated, and we need to have these keys in our application to be possible to authenticate our application. It is possible also, probably last example, I will try to run one example that creates partitioned collection. It will take some time. Collection is created, and after that we can have run. There are some specific things that I would like to mention. For example, for performance, to have connection mode direct, to have protocol TCP. It is something that is like property of our client object. Nothing very sophisticated. And finally, we receive some information from database. We need to read all this information. Sharded collection is created, and we received some kind of data. It is just simple example. And now I will just show you what we have in our database. Overview, we have our database. We have, we need to have collections. Okay. Just a second. So we need to see here collections that are created, probably. If I stop this and refresh interface, probably we will see it. Because it is a little bit complex feature, we need to see this collection. Okay, and we are able, using API or interface or web interface via management portal, to see collection elements, shards, and everything else. I really apologize that the connection probably is not very fast in this situation, because we need to receive some data. Here you will see all this data that we already inserted. So probably apologize for the 5 minutes with this delay. Thank you very much for the attendance, and hope that this information was useful for you. If you need any additional information, you can contact me directly, or you can contact the organizers of the conference, and we will provide you any additional information that you need. Thanks again.